Yes, so very good morning, ladies and gentlemen. This is your host, Meghana. Welcome to the second day of CAEV Expo 2023. We hope you had a great first day filled with valuable insights and networking opportunity. Let's kick off the day two of CAEV Expo 2023 with our opening session, which is focused on India's connected, electric, and autonomous shift, a roadmap to mass adoption. So without further ado, let's get started with our opening session. Our first speaker for the day is Mr. Surendar Kannan, a Vice President of Sales APAC and Japan at Cavli Wireless. Let's welcome him with a round of applause once again, please.
Ladies and gentlemen, good morning. My name is Surendar, and I represent Cavli Wireless. I would like to start this session with a very, very short and brief introduction about Cavli Wireless. As I guess it kind of helps to get a perspective of where we come from and what we do. So Cavli Wireless is incorporated in US, and but we have our global R&D based out of India. Our entire manufacturing is also based out of India. We design, develop, and manufacture connectivity modules to be specific cellular connectivity modules which power automotive use cases. So we are an enabler of connectivity for the mobility industry. So with this very short, is it echoing? Okay. With this very short introduction, let me get started. Okay, future of mobility is connectivity. Before we get into the future of mobility, let us look at the mega trends that is impacting the industry today. In my opinion, the best way to describe the trends would be using the acronym CASE, which stands for connectivity, autonomous vehicles, shared mobility, and electrification. Okay. Dynamic trends in connectivity and technologies have been transforming the automotive industry. And technologies such as autonomous driver assistance systems, 5G, artificial intelligence, and the increasing reach of V2X, vehicle to everything infrastructure, have been pushing the mobility industry into an autonomous driving functionality. On the other hand, we have innovations in smart mobility, in connectivity, which have been working towards achieving two overarching goals. One is enhancing the user experience, and the other is to improve what is good for the society. So from an user experience perspective, customers have been demanding for more advanced navigation, more personalized in-vehicle infotainment services, over-the-air updates, more preventive maintenance, so on and so forth. And from the perspective of what is good for the society, technologies have been striving for reducing the carbon emission, increasing the road safety, etc. So these trends are in a way interconnected. What I mean by that is the shared mobility platforms will use both autonomous vehicles as well as the electric vehicles. A lot of these electric vehicles will have autonomous functionality. Similarly, autonomous vehicles will be running on electric. But what is peculiar, or what is the highlight here is all these trends rely heavily on connectivity. Connectivity essentially places the vehicles as nodes upon the Internet of Things. Today, a vehicle is a service delivery platform as much as it's used for transportation and travel. So I think let me start with an interplay of connectivity with the various trends. And let's look at autonomous vehicles to start with. Yeah. So autonomous vehicles have been promising to revolutionize the way we are going to travel. If you look from a sales perspective also as well, the kind of revenue that is expected from autonomous vehicles by turn of this decade is anywhere between $300 to $500 billion. That's the kind of size of autonomous vehicles that we are discussing. And the other significant benefit of autonomous vehicles is it's kind of promising to enhance the road safety by several orders of magnitude. And by 2040, the number of autonomous vehicles on the road is likely to be around 80% of what the number of vehicles we have today. That's the kind of impact that autonomous vehicles is going to have on the mobility industry, be it from a technological perspective or from the commercial or business perspective, as well as from what's good for the society. Now, let's see how autonomous vehicles will depend on connectivity. I have 3 use cases to illustrate my point. Let's start with V2X, vehicle to everything. It's quite intuitive to imagine that autonomous vehicles will be relying heavily on V2X infrastructure to get an understanding of the sense of what the obstacles in the road are and what are the challenges they're going to face in the road. So autonomous vehicles will receive a lot of data from other vehicles, from the infrastructure, from even the pedestrians. And this data would be used by the autonomous vehicles to coordinate with the other objects in the V2X ecosystem for them to ensure a collision-free environment. So this is what we call vehicle platooning. And so V2X connectivity is extremely essential for autonomous vehicles to take critical decisions. From the point of view of development and benchmarking, the data from autonomous vehicles, or rather even the connected vehicles, or for that matter even the shared, the existing traditional vehicles on the road, helps to serve the development and improvement with regard to the future of autonomous technologies. Like data when presented in the form of the vehicle specifics, the traffic pattern, all these work towards powering the algorithms of the artificial intelligence and machine learning towards improving the technologies of autonomous vehicles. From the point of view of data production and connectivity, we all know that autonomous vehicles use a lot of data. To be precise, they use around 4 terabytes of data on an everyday basis. And this data is generated from various sensors like cameras, lidars, radars. And this data needs to be communicated to the various objects in the ecosystem. And this data also needs to be sent to the cloud for processing. So I think it's very fair to summarize the interplay as autonomous vehicles will rely very extensively on robust data connectivity for very long hours, possibly even in very harsh environments, to ensure fail-safe operations of the vehicles. I would like to move next to shared mobility, the next big trend. The shared mobility is making a big splash in the recent years, especially after the success of companies like Uber and Lyft. And today, all the services that you see on the screen, the car sharing, the bike sharing, are all something which is very common. We use it on an everyday basis. And possibly because of this, the shared mobility economy is performing exceptionally well. As per reports, it's around $100 billion globally today, and it is expected that by the turn of this decade, it should be around $300 to $400 billion, as much as what the autonomous vehicle revenue would be. And the other benefit of shared mobility is that you will have much lesser private vehicles on the road, which by itself would add to a lot of societal good, like more productive commutes, much lesser pollution, maybe much lesser vehicles on the road. So let us look at the interaction of connectivity with the shared mobility. Now, shared mobility by itself is a very vast ecosystem which is powered by automotive connectivity. The first use case I would like to discuss here is about the fleet connectivity. Now, a lot of fleet owners would take up to connectivity to track the vehicles, and with the success of more of the shared mobility platforms, you'll have more of them taking up to connectivity, but they're not going to stop with just tracking the vehicles. They are going to use the data from the vehicle to kind of understand more insights about how to reduce the fuel consumption, what better routes to take, how to ensure more optimized maintenance, so on and so forth. Similarly, the routing and navigation data. The routing and navigation data is also very critical for the players across the shared mobility spectrum. So here again, data presented as insights in terms of the road conditions, whether the road is blocked because of an accident or something else, or various other insights would help the shared mobility customers to take very informed decisions as they go about ferrying their passengers and picking up their rides. And the last use case I have with regard to the shared mobility trend is the innovative insurance. As the number of the private vehicles on the road would reduce, so would be the revenue loss for the insurance companies. So these insurance companies would try to come back with more innovative insurance policies, such as usage-based insurance. And once these shared mobility customers who kind of subscribe to this insurance only for the duration of the specific drive, the insurance companies have to take up to connectivity to kind of track these vehicles, understand the driver behavior, assess the safety risks, and thereby calculate the premium for these insurances. So this kind of takes me to the last trend, which is about electrification or electric vehicles. So electric vehicle, like shared mobility, is also here to stay. The proof is the fact that the month-on-month and year-on-year sales growth that we see of electric vehicles. I read recently, last week, that in India, around 1 million electric vehicles have been already deployed. It's already $1 billion industry in India. And by, again, turn of this century, by turn of this decade, around 2030, we should be having around 30 to 40% electric vehicles on the road. Plus, there's the entire government machinery which is behind it, which obviously is doing it for ensuring the positive influence on the climate change, reducing the dependence on fossil fuel, so on and so forth. So as autonomous vehicles are revolutionizing the way we travel, I guess electric vehicles would go one step further and even revolutionize the way we are going to lead our lives in a more healthy fashion and our economy in a more healthy manner. So when I look at the interplay of connectivity with the electric vehicles, I have shortlisted 4 use cases. I'll start with the OEM performance tracking. Whatever said and done, the electric vehicles are still in the nascent stage. The technology of electric vehicles are still in the pretty nascent stage. And the R&D engineers and EV companies are very keen to track the performance of these vehicles to understand any bugs or any improvement points based on which they can keep improving the technology, for which they have to rely and take up to connectivity as well. The second use case I have is with regard to the charging infrastructure planning. It is the data from the electric vehicles which would come in handy for these companies to kind of assess and determine the demand for charging stations. The location intelligence which comes from the historical traffic data would throw up a lot of insights with regard to the driver behavior and where the EV drivers are, which places they are going, at which point the battery is starting to drain. And all these information would kind of come in handy to ensure the demand for electric vehicles and demand for the charging stations and where they have to be deployed. The third use case is about simplified trip planning. So one of the biggest challenges with regard to the electric vehicles as of today is the range anxiety. So I'm sure there'll be quite a few business cases which is going to come up quite soon to address this anxiety. And what would happen is these AI-enabled solutions would power the services to overcome these challenges by utilizing various vehicle data, such as the location of the vehicle, the residual charge in the vehicle, the destination to the balanced distance to the destination, the temperature conditions, the road conditions, and all this will be used by the AI-enabled solutions to come up with various recommendations to the driver on where they can go and charge their vehicle and what's the best route to reach their destination. And finally, the policy updates. So like how the insurance companies have been dropping their uh, revenue because of lower private vehicles on the road. With the drop of sales of petrol and diesel, I'm sure the revenue for the tax agencies will also drop. So to overcome this, I understand that a lot of countries and governments are already assessing the ways of taxing the electric vehicles. And vehicle miles traveled is one of the key attributes which they are considering to use for taxing vehicles, which is also a very accurate data which is going to come from the electric vehicle as well. So with this, I think what is quite clear is that there are quite a few enablers in the connected vehicle ecosystem, and connectivity provides something for almost all the enablers in the connected vehicle ecosystem. It provides something for the government. It provides some attributes for the insurance companies, some attributes for the OEMs, some attributes for the fleet owners. And all these enablers would come together and leverage connectivity for enhancing their bottom line, and thereby push the engine of the automotive industry forward. So at this context, I would like to draw your attention to three enablers which are connectivity related, purely connectivity related. In Cavli, we call them the building blocks of automotive connectivity. The first one is the connected module with the integrated eSIM. So this connected module is something which sits in the telematics control unit or the vehicle control unit of the vehicle and transmits data to power many IoT use cases. Now this comes in various flavors depending upon, for example, which network type are you in. Today 4G is very popular, 5G is just around the corner. Maybe very soon we'll also have 6G based modules. And then it also depends upon what kind of complementing technologies you would require. Like complementing technologies could be GSS, GPS, the positioning technologies, or cellular V2X kind of technologies in case it's required for the autonomous vehicles. Similarly, the human-machine interface. Like in case you need a phone kind of an human-machine interface, then you take up to Android, or you look at Linux or ThreadX. And finally, the various interfaces that is required. So typically these modems come with interfaces to the CAN bus, interfaces to the display, interfaces to the camera, so on and so forth. The second is the vast telecom providers network, and then finally is the connectivity management platform. In many cases, the connectivity management platform is the unsung hero because not a single operator would be able to assure connectivity to the vehicle wherever it goes. So it's the connectivity management platform's responsibility to be the critical link between the vehicle, the telecom network, and the various services that ride on the telecom network which power the automotive use cases. And it's a connectivity management platform which does this by switching the profile of the operators and ensure the best connectivity is always available for the vehicle. So this is my last slide. I would like to provide you a comprehensive set of the Cavli portfolio. The good thing is we have all the three critical connectivity blocks in our portfolio. We have a wide range of modules, and we have a connectivity management platform. It's called Hubble, and we have tied up with around 7 global tier 1 operators where we can provide connectivity in around 160 countries. So with this, I would like to conclude. Thanks a lot for your time, and I'll appreciate if you can drop by a booth. We are at ZC88, and we can continue our discussion over there. Thank you.